Hello Year 12 and welcome to Purple Mountain Maths. We are doing the 2025 HSC paper for Mathematics Advanced. This is part 9, question 27 and 28, together worth 10 marks. Question 27. The shaded region is bounded by the graph y equals a half to the x, the coordinate axes, and x equals 2. Part A. Use two applications of the trapezoidal rule to estimate the area of the shaded region. Pause here to try yourself. Okay, so let's first of all make sure we understand this graph. When x equals 1, y will be a half to the 1, which is a half. So I know it goes through this point here, 1 comma a half. And when x equals 2, 1 over 2 to the 2 is a quarter. So we know it goes through this point, 2 comma a quarter. And we're invited to use the trapezoidal rule. So the trapezoidal rule, straight off the reference sheet, says that when you're differentiating from a to b, it's approximately equal to b minus a over 2n f of a plus f of b plus 2 times the points in between. As shown. Now in this case, the points we have to play with are 0, 1, 1 1/2 and 2 1/4. So in this case, point A is 0, point B is 2, and we're going to do 2 applications. So that area equals 2 minus 0 all over 2 lots of 2 outside of. Now f of A is 1 and f of B is a quarter, and we're going to do 2 lots of the point in between, which is a half. So I've got 2 quarters of 1 plus a quarter plus 1, so this is 9 over 4. A half of 9 over 4 equals 9 over 8 square units. Part B says show that the exact area of the shaded region is 3 over 4 ln 2. So I would be able to find the exact area if I integrated from 0 to 2 of the function, which is a half to the x dx. So it's 0 to 2 of 2 to the minus x dx. I could create a minus sign by placing one both inside and outside my integration. And now I can change what's on the inside to 1 over ln 2 times 2 to the minus x. And I'm going to evaluate that from 0 to 2. 1 over ln 2 is just a constant. I can pull that out the front. And so I've got 2 to the minus 2 subtract 2 to the 0. I can push that minus sign back in there. It's 1 over ln 2 of 1 minus a quarter, which is 3/4. So I get 3 over 4 ln 2 as required. Okay, part C. Using your answers from part A and part B, deduce that E is less than 2√2. Okay, so we need to think about creating an inequality. We did notice that the curve is concave up, and that means that the trapezoidal rule is an overestimate in this scenario. So my answer that I achieved from part A exceeds the real answer of 3 over 4 ln 2, which was my answer for part B. Now I can multiply both sides by ln 2. Note that ln2 is a positive number, so 9 lots of ln2, I can also multiply by the 4 at the same time, is greater than 3 lots of 8. So I get 36 ln2 is greater than 24, or ln2 is greater than 24 over 36, which is 2/3. 3 ln2 is greater than 2. Let me push that 3 up here. 2 to the 3 is greater than 2. So rewriting the other way around, I get 2 is less than ln8. I could raise both sides using e. E squared is less than 8, or e squared is less than 2√2 all squared. So e is less than 2√2. Question 28. A farmer wants to use a straight fence to divide a circular paddock of radius 10 metres into 2 segments. The smaller segment is 1/4 of the paddock and is shaded in the diagram. The fence obtains an angle of theta radians at the centre of the circle as shown. Part A. Show that theta equals sine theta plus pi on 2. Pause here to try it yourself. Okay, so we can see that the area of the segment equals the area of the sector less the area of the triangle. So that is 1/2 r squared theta less 1/2 r squared theta sine theta, factorising on 1/2 r squared, that is theta minus sine theta. But we're also told that the area of this segment, the part that's shaded, is 1/4 of the whole circle. So 1/4 of pi r squared equals that. So I could divide both sides by r squared. I could halve the left-hand side as shown to get rid of that, and I'll just be left with theta minus sine theta. Or in other words, making theta the subject of the equation, theta equals sine theta plus pi on 2 as required. Part B gives us the graph of y equals sine theta plus pi on 2. We can see that that is a sine wave that's been translated up by pi on 2. Use the graph and the result in part A to estimate the arc length of the smaller segment to the nearest metre. So we need to solve theta equals sine theta plus pi on 2. So this is the intersection of the straight line y equals theta and the curve above. So let's do that. Let's draw a straight line which is y equals x, and it is the line y equals theta. It will intersect with sine theta plus pi on 2 here, which is 2.3 radians. The solution, theta, is approximately 2.3 radians. Given that, we need to find arc length. L equals theta times r, which is 2.3 times 10. So we get L equals 23 metres, and that's our answer. That's the end of question 28. It's the end of part 9.